Good morning, all. Just letting folks access the webinar. We'll get started momentarily. We're just watching our participant numbers climb, folks. We'll get started in just a few moments. Good afternoon or good morning, depending on your time zone. And thank you for joining us today for an online briefing and conversation about advanced nuclear energy development and deployment, sponsored by the Nuclear Innovation Alliance, or NIA. In today's conversation, we'll be sharing updated versions of NIA's primer on terminology and compendium on companies, and new maps highlighting the locations of planned and proposed advanced nuclear energy facilities. We'll also be talking with leading industry representatives about their projects and latest updates. My name is Ben Finzel. I'm the president of Renew PR in Washington, D.C., and I have the pleasure and the privilege of supporting NIA on communications, and I'll serve as moderator for today's event. I'm going to introduce NIA Executive Director Judy Greenwald in a moment, but first, I'd like to share just a few notes about our agenda for today's conversation. After Judy provides an introduction, NIA Innovation Analyst Victor Ibarra Jr. will share highlights of the new primer, compendium, and maps. From there, I will introduce our three panelists who will talk about the latest developments and updates in their companies, and then help field questions from all of you in an open Q&A. You're welcome to start asking questions now by typing your question, your name, and your affiliation in the Q&A box. Once we begin the Q&A session in about 20-30 minutes or so, I'll do my best to take the questions in the order in which they are received. And if we don't get to all of them, we'll make sure we follow up with you by email. But first, let's get started with comments from NIA Executive Director Judy Greenwald. And Judy is going to share with us a little bit about NIA and these new resources. Judy, thanks for getting us started.
Thanks, Ben, and welcome, everyone. We appreciate you joining us for this briefing on the release of our annual updates to our Advanced Nuclear Technology primer and our Company Compendium, and the debut of our new deployment map. I'm thrilled that we'll be joined by leading advanced reactor developers to talk about the latest commercialization news. NIA is a nonprofit, nonpartisan think and do tank working to create the conditions for success for advanced nuclear reactors as a climate and energy solution. Through research, analysis, and education, we inform decarbonization and innovation policy. We played a leading role in informing major federal legislation to reform advanced reactor licensing at the Nuclear Regulatory Commission and to expand the Department of Energy's nuclear innovation efforts. We also collaborate with stakeholders to coordinate advanced reactor advocacy in the United States. NIA staff members Victor Ibarra Jr., Patrick White, Mario Gomez, and Eric Cothran updated and created these new and improved NIA resources that we'll be highlighting today. We're so fortunate to be joined by three panelists from USNC, Oklo, and Dow to discuss their innovative nuclear energy projects and highlight the relevance of the updated primer, company compendium, and deployment maps. Before we begin, let me share a little background on these resources. We created the new Advanced Reactor Deployment Map to provide a visual representation of advanced reactor projects initiated in North America. The interactive map shows where and when proposed reactors are expected to be deployed. We know this map will need to be filled with many more projects for us to meet our climate commitments. We first released our Advanced Nuclear Reactor Technology primer in September 2021 and have updated it annually. It's a 101 document to demystify advanced nuclear reactors and explain the characteristics of the most common types and leading designs. The primer serves as a guide for media, policymakers, stakeholders, and anyone else who wants to understand the rapidly evolving advanced nuclear energy space. We first released the Company Compendium in July 2022, just last year, as an introduction to the advanced reactor business ecosystem for potential investors and other key stakeholders. The compendium includes brief descriptions of the companies and other entities associated with the planning, design, testing, construction, and operation of advanced nuclear energy projects. It also highlights leading advanced reactor developers and summarizes publicly available information on agreements between developers and the private sector, government, universities, and other organizations. It's a complementary piece to the primer. All three of these documents are resources you can use to understand the size, scope, and progress of advanced nuclear energy commercialization in the United States. So back to you, Ben.
Thank you, Judy. I'm pleased to introduce NIA Nuclear Innovation Analyst Victor Ibarra Jr. for an overview of the Primer Compendium and maps. And Victor did a good deal of the work to update these documents, so we have him and his colleagues to thank for making them available. Victor, over to you.
Awesome. Thank you so much, Ben. Let me quickly share my slide deck that I'll be using for today's presentation. If everyone can see that, that'd be great. I can start now. So at NIA, we see real value in making sure that current information about advanced reactors is accessible. It really helps straighten and contextualize everyone's understanding of the broader value proposition of advanced nuclear energy technologies, and also enables more effective public and private discussions with companies, policymakers, investors, and other stakeholders. Nuclear energy is also a rapidly evolving commercial field, with companies building their supply chains and deploying their technology now. Our updated Advanced Nuclear Energy Company Compendium and our updated Primer are two examples of NIA resources that can help provide this kind of up-to-date information. Our newest resource, our NIA deployment maps, will also complement these two resources to give stakeholders an additional tool that they can point out when analyzing, discussing advanced reactor deployment. In my discussion, I want to highlight some key updates that we made to our Primer and Company Compendium. This includes addition of new companies, updated deployment timelines, updates on agreements, awards, and site locations that have been announced over the last year. Specific examples that I can point to are the addition of new companies like Radiant Energy and the addition of a new reactor design like Westinghouse AP300 design. We also have information about GE Hitachi's technical collaboration agreement with the Tennessee Valley Authority, Synthos Green Energy Group, and Ontario Power Generation to deploy reactors, GE Hitachi's reactors in the United States, Canada, and Poland. We have information about Kairos Power's construction permit application to the Nuclear Regulatory Commission for their Hermes demonstration reactor, and their latest announcement of the Hermes 2 construction permit application that was only recently submitted a few weeks ago, if you missed that. We also have information about X-Energy's decision to move forward with Dow Chemical as their advanced reactor demonstration program partner, and also recently announced their joint development agreement announcement with Energy Northwest to continue as a deployment partner in the state of Washington. We also have updated information about other microreactor designs, including Oklo, Project Pele, BWX Banner Reactor, and USNC. It really is an exciting time to be involved in advanced reactor innovation and commercialization, and it's crucial that we really continue this momentum into the future. We really hope that these resources can be helpful to a broad group of stakeholders engaging in advanced nuclear energy innovation, commercialization, and investment. Next, I really want to highlight our newest resources, which is our NIA deployment maps. So this discussion will include a live demo of how to use these maps. And as previously discussed, there's a lot of rapid progress in development and deployment in first-of-a-kind reactors. Companies are selecting sites, finalizing their design details, and developing their first license applications for their first projects. And deployment timelines have been announced for being completed as soon as the mid-2020s and the late 2020s as well. So it's really exciting that we've been able to develop this map, because this is something that stakeholders can point to and say, look, advanced reactors are here and will be deployed before you know it. Highlights of our deployment maps include summarizing all the information you might need to know about a reactor design, including the type of reactor it is, whether it's a high temperature gas reactor, molten salt reactor, its location, who advanced reactor developers are partnering with to get this done, whether it's Ontario Power Generation, a university like the UIUC, and the year you can expect this reactor design to be deployed. In North America alone, as you see in front of me right now, we have 13 advanced reactor companies hoping to deploy over 35 reactors, some with firm contractual agreements already in place. As Judy discussed, to meet our clean energy and our energy security goals moving forward, we need to deploy a lot more of these reactors, but we really hope this tool can be an invaluable resource for you to show the rapid pace at which these technologies are coming online. So, for example, today we're gathered by a few panelists, and I'll let them discuss their technologies later in this panel. But if I can point to a bullet on our deployment map, you can hover over it and see what kind of information you might need about the reactor design, including its reactor scale, whether it's micro or SMR, its reactor type, whether it's a high temperature gas reactor, and even a source that you can copy and paste into your web browser if you want to learn more information about this site agreement or technology agreement moving forward. We really, really think that this is going to be an invaluable resource to help policymakers shape some of their future decisions, because this will show the rapid pace that a lot of advanced reactor designs are coming online. Similarly, I also want to point out that it's not just one map we created, it's two maps that we created. We also created a Eurasia deployment map, so all the deployment maps of North American designs that are hoping to deploy in Europe and Asia. And this really showcased how American advanced reactor designs companies are leading the way in nuclear deployment. On our deployment map that we show here, we have 5 reactor companies that will account for about 20 deployments across Europe and Asia to help in their clean energy and climate security objectives. To wrap up, all of these resources are intended to be living documents, meaning that we'll update them with new information, add new companies, and include new details. And we'll publicize updates and share new versions as appropriate in the months and years ahead. You know, updating this information is very, very fun to me. So I really hope that everyone can reach out whenever they can so we can add more information to both the Eurasia and North America deployment map as necessary. The best way to keep track of these updates is to follow us on Twitter at the NIA.org and LinkedIn at Nuclear Innovation Alliance. And now that we're covered our resources, I would like to pass it off to our amazing panel that we've gathered here today, who will introduce by Ben Fizzle from Renew PR. So Ben, let me stop sharing screen and over to you.
Thanks, Victor. These are great resources, and now that we've seen them, super helpful. They should be very useful to industry stakeholders and to media, both of whom are joining us for this call today. I should point out that all of these resources are now live on the NIA website on the resources page. We encourage you to download them for your use throughout the year at www.nuclearinnovationalliance.org. And if you have a question, you're welcome to start putting it in the Q&A section now, along with your name and affiliation. You can beat the rush and get in early by typing your question in now. But first, the main event, I'm super excited. It's not just about these resources, it's also about the voices and the people and the insights from the industry leaders who are actually doing all of this work. So I'm excited to introduce our industry panel to give us some real world insight. First, we're going to hear from Archie Manoharan, Director of Nuclear Strategy at the Ultra Safe Nuclear Corporation. Then we'll hear from Mark Feltner, Senior Nuclear Technology Manager at the Dow Chemical Company. And finally, we're delighted to welcome Oklo CEO and co-founder Jake DeWitt to hear about his company's latest updates. I'm going to let each of our special guests talk in turn, so I won't come back to introduce each of them again in between. It makes the conversation flow much better that way. So I'm going to turn it over to Archie, and then we'll hear from Mark and then Jake. So Archie, take it away.
Thank you, Ben. Just double checking. Can you hear me?
Okay. Yes.
Great. So thank you so much. Good afternoon, good morning, wherever you are. Thank you to NIA for this opportunity. I'm thrilled to be here with my co-panelists, excited to represent USNC here. I would like to start with USNC's vision statement, which is reliable zero carbon energy anywhere. And the way we have set out to achieve this vision is primarily through our micro-modular reactor, a high temperature gas reactor, which uses our patented FCM TRISO fuel, which is fully ceramic micro-encapsulated fuel. So the MMR and the FCM are our flagship products. And what makes us ultra safe really is an aspect of our fuel. We take TRISO, which is already safe, and we add another layer of safety by encapsulating it in our proprietary FCM fuel and making it safer. By making the fuel safer, we're making our reactor safer. And we're obviously very proud and thrilled to kind of share the design aspect of our fuel and our reactors. We're even more proud of the fact that we are building the capability to manufacture this fuel. We just accomplished at our Oak Ridge facility the ability to manufacture TRISO and FCM fuel, and it also has the capability to produce other advanced fuel forms. In fact, recently, we were able to deliver TRISO-coated particles to NASA to support their space nuclear program. And we were really thrilled, especially the fuel team, by this accomplishment. We were able to do this quickly and efficiently, thanks to the breakthrough 3D printing abilities we are building in Oak Ridge and the advanced manufacturing technologies we're building there. This is our commitment to not only improving the design aspect, but also improving the manufacturing and supply chain capabilities on our end. We're also de-risking future commercial projects by focusing on licensing of demonstration projects now. We currently have 2 demonstration projects, one in Canada at the Chalk River Lab, being done in partnership with Ontario Power Generation under partnership called Global First Power, the other at the University of Illinois at Urbana-Champaign. Getting the regulatory reviews, both at CNSC and NRC, obviously is a good de-risking and important step for future deployment for the MMR design. And we think it's an important step for future deployment. A lot more dots on the NIA. CNSC is leaning into new market demands, looking beyond our 2 demo projects. Our pipeline is growing, and we want to grow along with it. To that end, we have selected a site for our MMR manufacturing and assembly in Gadsden, Alabama. We're working towards finalizing plans for this essential advanced nuclear infrastructure right now. This will be a state-of-the-art facility. It represents around $232 million of investment. And I'm personally very excited about this. It will be creating somewhere around 250 quality manufacturing jobs in the host community area. And we expect construction to start next year and the facility to begin operating in 2027. This facility, once it starts operating, is expected to produce about nominally 10 MMRs per year. We think that that is going to be the right direction for us to meet new markets, new demands, and head in the right direction. Our FCM fuel makes the MMRs safer, simpler, and available to new markets and new customers. And that makes our vision achievable. New markets mean new customers, new demands, and new questions. The NIA primer and compendium help familiarize these new customers with the advanced nuclear technologies out there. The NIA resources will help the new customers inform them about the advanced nuclear technologies out there, like the MMR, FCM fuel, and others, and help them understand how these advanced nuclear technologies can help meet their company's vision for reliable, zero carbon energy anywhere. And the fact that we have Dow Chemical on this panel is an example of how the game is changing, new players are being added, which is a great thing for the entire industry, in my opinion. And with that, again, appreciate the opportunity to represent USNC on this panel, and over to you, Mark.
Thanks, Archie. Good afternoon, good morning, everybody. Again, I'm Mark Feltner. I'm Dow Senior Nuclear Technology Manager. I've worked at Dow for almost a year now, but before that, I had a 35-year career at Entergy's Riverbend Station. Really appreciate the opportunity to talk about Dow's advanced nuclear projects and our partnership with X-Energy. Thought I would start giving you a sense of our decarbonization efforts at Dow and how our partnership and the project with X-Energy ties into those decarbonization efforts. We absolutely at Dow embrace our responsibility to accelerate work to reduce our global emissions. We've already done an admirable job in that. We've reduced our greenhouse gas emissions by 15% between 2005 and 2020. And we're on track to reduce emissions by an additional 15% between now and 2030, with an overall goal to be carbon neutral by 2050. This challenge of decarbonization is very significant, but it is achievable. To make our products, we produce more than 7 gigawatts of power and steam at approximately 30 major industrial sites around the world. That energy powers more than 50 gas turbines and steam turbines and boilers, as well as over 100 furnaces, again, around the world. We at Dow are already a leading user of clean energy in the chemical industry and a top 20 among global corporations, having secured over 1,000 megawatts of renewable power for use at our Dow manufacturing sites around the world. However, there is a limitation in the ability for renewables to support our decarbonization efforts. Dow's strategy is to decarbonize and grow, meaning that we are investing in both growing our ability to serve our customers while reducing our overall carbon emissions. We're investing about $1 billion a year to drive growth and decarbonize our manufacturing assets. We have a detailed investment plan and a roadmap to our 2050 carbon neutrality target that touches nearly every aspect of our chemical business. One important part of this strategy is to replace our end-of-life assets with known, proven technologies that enable us to decarbonize, preparing our sites for a more sustainable future. We consider nuclear energy, especially the promising technology of advanced reactors, to be a long-term viable source of sustainable, zero-emission electricity and steam for our manufacturing operations. Advanced nuclear has attractive advantages over other sources of clean power, including its compact footprint, its competitive cost, and its enhanced power and steam reliability. We also believe that advanced nuclear can be helpful in the future to generate hydrogen from electrolysis, which will be critical to the decarbonization of high heat industrial processes, and hydrogen can be blended with natural gas to reduce overall CO2 emissions. As for our partnership with X-Energy, we first announced that we were going to work with X-Energy back in August of 2022. And earlier this year, we entered into a joint development agreement to demonstrate the first grid-scale advanced nuclear reactor at an industrial site, which we will build at our manufacturing facility in Seadrift, Texas. X-Energy's technology can provide clean, reliable, and safe power to the electric grid. Each reactor can produce about 80 megawatts of electric output or 200 megawatts of thermal output, high pressure, high temperature steam for industrial application. Our plan at the Seadrift site is to install 4 of these reactors. The project is expected to reduce Seadrift site emissions by approximately 440,000 metric tons of CO2 per year. We selected the Seadrift site because it is an important manufacturing site for current and future products. With additional growth coming to the site and existing energy and steam assets nearing their end of life, we saw the opportunity to replace aging assets with safe, reliable, lower carbon emissions technology. The Seadrift site covers 4,700 acres and manufactures more than 4 billion pounds of materials per year used across a wide variety of applications, including food packaging and preservation, footwear, wire and cable insulation, solar cell membranes, and packaging for medical and pharmaceutical products. One advantage for us is that the region is familiar already with nuclear technology, as our site is located approximately 50 miles from the existing South Texas Project nuclear facility near Bay City in Texas. Dow and X-Energy are in the process of preparing a construction permit application to the Nuclear Regulatory Commission, an important milestone to bringing this project to fruition. And construction at our site is expected to begin in 2026 and to be completed by the end of the decade. We absolutely appreciate the work of the NIA to educate stakeholders on the opportunities on the opportunities that advanced nuclear technology offers. As we've engaged in our project, one of the most critical elements of our work thus far has been to educate stakeholders about our project. Our employees and their families, the community near the site, our investors, our customers, they're all critical to enabling us to follow through with this project. As we've engaged these stakeholders, we're getting a lot of feedback. First, there's definitely a greater acceptance of nuclear technology than in years past, as people are beginning to understand that a low carbon world can't be achieved on renewables alone. With that said, however, there's still a lack of understanding and oftentimes misconceptions about the safety of nuclear. Understandably, people ask us every day about the risks, whether it be about nuclear waste or about the safety to the community as a whole. Therefore, the work of the NIA and its members to educate stakeholders is critical. We have a lot of work to do, and the team at Dow is glad to be part of it. Thank you, and I look forward to taking questions. And now I'll pass it over to Jake.
Thanks, Mark. Appreciate being on the panel here and everyone joining today and the opportunity, and of course appreciate the work that NIA has put into this report. It's a pretty exciting time in the nuclear industry, and as someone who grew up in New Mexico around this technology from a very young age, obviously seeing the Oppenheimer movie was a bit of a treat to sort of build on top of this, or as a preamble to this report. But I do think, as Mark was saying and Archie were talking about, this is marking a significant time of growth and expansion for nuclear. I think one of the things that stood out to me for a long time is advanced nuclear is going to play a very important role, not just in the US, but in the world's overall energy future. And we're seeing that manifest now. It's not so much it's happening at some point in the future. It's happening now, and it is growing. At Oklo, we're pretty excited about some of the recent announcements we've had. We're working on effectively an implementation of a next generation fast reactor design technology, wonderfully demonstrated by our national research and development laboratories, particularly Argonne National Lab and Idaho National Lab, manifest specifically with a plant that ran in Idaho for 30 years called the EBR2 plant. And we're excited to bring a modernized version of that to market with a bit of an innovative approach on the business model and go-to-market strategy, all of which I see as part of the diverse spectrum of offerings coming from a resurgence in sort of nuclear entrepreneurialism, nuclear enterprise, nuclear innovation, to realize the potential this technology has in a manner that's going to match what the needs are of it. The burden is on us to do that, and it's a pretty exciting opportunity space. At Oklo in particular, we're developing and building our first plant out at Idaho National Laboratory. It is a full commercial plant. We're very excited about the partnerships we have with the lab there, with the Department of Energy, having a site use permit for that plant, as well as having fuel awarded to us to support building that plant and producing power. We spent a lot of time in a regulatory process to engage on that. Additionally, we've had announcements about building 2 more plants in Ohio. Another wonderful story about taking a site that had a lot of nuclear infrastructure and legacy associated with it and bringing it forward to put new projects on and bring forward the benefits that advanced nuclear technologies can afford to the community as well as to the local customers for the power base there. We've got more in the pipeline, excited about what that future looks like. That said, there's obviously a lot of work ahead. One of the things I think I get most excited about when I look at what's happening across the board here is the diversity of approaches being taken from a technology perspective, from a business model perspective, from a go-to-market perspective, from a financing perspective. You're seeing a diverse pool of capital line up to support these things, further accelerated and enhanced by policy support, including from the Inflation Reduction Act and what it's enabled in terms of investment tax credits for nuclear, for expanded production tax credits, for the Loan Program Office support, as well as investments in fuel infrastructure and supply chain capacity. I think there's room for more and for growth for that to support the inevitable I think role nuclear is going to need to play. And when you look at the Department of Energy's recent liftoff report that looked at more or less tripling nuclear capacity from today to get us to our goals by 2050, we're going to need that to kickstart this and ensure we can meet those goals at the times we need to. But going back to my comments on the diversity of approaches here, what I think is very exciting by that is it offers solutions to meet a number of different market opportunities. We've already heard about from Mark what Dow is doing. You've heard some about what Archie and USNC are working on. all of which have different complementary and also differentiated opportunities to meet market demands and segments that are looking at how they can transition or grow their energy footprint sustainably and decarbonize in the process. What that entails is a bright future ahead for everyone. People sometimes talk about having many shots on goal is a good thing. It's absolutely a good thing. And a neat thing about this space is the goal is very, very, very large. So a lot of those shots are going to score just because of the nature of how this market is going to be and what this lines up to do. This is a bit of a different paradigm from, I think, where nuclear has been in the past, one that was more constrained by, frankly, I think a bit of a scarcity mindset that was more centered on what government funding cycles might go from one to the next, not seeing necessarily the clarity in the demand picture. We're in a different world now. The demand for clean, reliable power that nuclear can uniquely provide is immense, and it's only going to be growing, which means that we are now entering an age, I think, of abundance in how we think about not only developing these technologies, but taking them to market. Some of the things we've been proud at Oklo is trying to do things in a bit more, I would say, iterative fashion in certain areas, particularly on the regulatory front. We've had our ups and downs there, but that's part of the progress to make that's part of the progress to make progress, where we found that, along the way, we've been able to push forward some very different ways of doing things, modernized thinking, and found that there's some things that have worked quite well. And we hope that that benefits all in the industry, not just what we're doing. And so we're pretty excited about how that's lining up with respect to our engagement with the NRC and how that's continued and how that's going to support us submitting applications for those sites as well as others coming in the pipeline. But just to go back to sort of a higher level at the beginning of this call, I think one of the things that we see as a significant opportunity for going forward is looking at and using the resources NIA has put together about how these things are indications of the market recognizing the interest here, how this is going to play a role going forward in the future, the technology specifically, and how significantly, or how large that opportunity really is. That's ultimately going to manifest in a variety of policy support levers. Some we've started to pull, some will need to be pulled more, I think, to fully enable us to realize our goals as a society and a country with respect to maintaining energy reliability while also ensuring decarbonization and also being a leader on the global stage. There's a lot of opportunity for the US to lead in this space. And if we do these things in the manner to reflect what's happening internally here and support and nurture those pieces through the investments we've been making and more investments to come, will position this industry for a lot of success as also an export leader to support global decarbonization goals as well. I think it's a pretty exciting time in this space, but it's really just kind of the dawn of sort of a new era with respect to what's coming and what's happening. I hope we all sort of kind of reflect on that, feel that responsibility, motivated by it, but also embrace that opportunity that affords. So appreciate everyone's time here on this and happy to hand it back off.
Well, what a shame that none of you had anything substantive to say. My goodness, I could not keep track of all of the developments and the exciting time it is, Jake, indeed. And I want to just underscore a point Archie made about Mark's involvement, right? This is not just for all of these exciting new developers like Oklo and USNC and X Energy and others. It's also established mainline companies that are understanding that they need to really think about what the future looks like in terms of energy production, and Dow is right there at the forefront of doing that. So wonderful to have this conversation. Thank all of you for that terrific update on the state of the industry right at this very moment, although it changes pretty much every day. There's a lot happening. I know we've just scratched the surface. There's lots more to come from all three of you. And as we've seen, as you pointed out, Jake, by the primer and the compendium and the maps, there's a lot there, and there's going to get a lot more. We'll fill in a lot of those dots. Let's get to the Q&A. Some of you have already started putting questions in, which is awesome. Thank you. Our NIA staff is back on camera as well. So all 5 of you are going to be there for the questions. As a reminder, if you could include your name and affiliation as well as your questions so we know who we're talking to, that would be super helpful. The first one is from Ben Cross, and it's for Oklo and USNC. And he asks, how do you see your reactor playing a role in integrated energy systems as envisioned by DOE H2 to Scale program, and at least in part is being proposed by X Energy and Dow? Not sure who wants to go first there.
I can take a stab at it.
Okay.
For the MMR nuclear batteries, it can supply power and heat to decarbonize generation of hydrogen, including electrolysis, thermochemical splitting, and other innovative solutions. So the target industries would be like petrochemicals and ammonia and green steel, refining, transportation. So we see a lot of scope there, and the design itself is able to be a huge player in that particular area. I don't know if that necessarily answers the question, but it is a fit, and it's a play and fit model. So I think that the MMR nuclear battery is very much a player in the hydrogen generation aspect.
Jake, do you want to add anything?
I think Archie hit that pretty well. There's obviously opportunities about what you can do with the products of these things, and the different size ranges and different partnerships are going to create different infrastructure opportunities around hydrogen that I think are pretty exciting.
Good, thank you. I'm gonna, Ben has asked a couple questions. I'm gonna skip down just to get some other folks in the mix here. Doug Vine from C2ES, hi Doug, has a question for Jacob. Can you talk more about the nature of the projects in Ohio? Is there any industrial heat involved, or is this purely a clean electricity project?
Yeah, a primary focus is on clean electricity. However, we are talking with some potential offtake users on the heat side. So it is a possibility there, but the primary focus is on the power, the electric power.
And Mark, did you want to add anything to that? I saw a note there that you might want to.
No.
Okay,
Sorry.
great.
Yeah, no, nothing there. Thanks.
No problem. I'm going to go back to Ben's questions. So co-location to energy intensive, especially thermal intensive end users, is essential for nuclear to meet their energy needs. So what are your plans to get regulatory approval from NRC along with the other applicable regulatory agencies? Well, there's the $64,000 question, right?
I can start with that, Ben.
Sure.
So at least from our project, since we are an industrial application of nuclear, using that as a cogeneration facility, really the regulation is no different than if I was getting the license for doing an electrical plant. I mean, the bottom line is we're creating steam, we're creating electricity, and both of those will be used by our particular Seadrift chemical site, and really doesn't impact the licensing. And right now, the conversations that we've engaged with the NRC have been very positive regarding the relationship and the planned usage, as well as the timing for the regulatory approvals.
Thank you. Anyone else want to jump in? Okay, I'm going to move down. Oh, go ahead.
Oh, go for it. No, I think Mark hit that well.
Okay. I'm going to move down to a question from Kay Kaufman at RTO Insider. And Kay asks, can you talk about the current state of the domestic supply chain and particularly fuel? Another big question.
Yeah, I'm happy to jump in real quick on this. I think this is one of the biggest, sort of choke points in terms of looking out over the next few years for the deployment for new nuclear plants. I think what you see between obviously I think an intentional effort and focus to make sure we can onshore, or at least to use the term friendshore, the fuel supply chains for our existing plants as well as our new plants is a priority. So we need to think about how we can kickstart that and drive that forward. I will say I think the support levels we've seen are a starting point, but just that, a starting point. As you see on these maps, the opportunity space for new projects is huge, and I think that's in light of fuel scarcity being a challenge over the next few years. I think there will be just more that comes to the table, and the more we can open up fuel supply capacity and establish that to be able to meet and grow with what we're seeing here, the better. I think, frankly, most folks are underappreciating how big this is going to be, and I think some policy support that enables the right kind of scale up on the fuel supply, the front end of the fuel cycle, is going to be critical for sort of kickstarting this. Not just for what we're doing domestically, which is obviously huge and a massive shift from where we are today, but also to lead internationally, right? Just to think back a little bit, in the 1980s, the US led the world in enrichment capacity. I think it may have even had more than the rest of the world combined, and we've let that lapse. It's time to bring that back, and it's time to kickstart that capacity build out now, so we can try to keep up with the wave of orders that are starting to pile up and coming on the horizon.
Thank you, Jake. Archie, did you want to add anything, or Judy?
I think I'll just second what Jake said. I think that was very well articulated. If you hear the industry talking, the supply chain on the fuel piece comes up every time, and it's brought up in every meeting, and we should bring up every meeting because it is really an important element that we need to address from top down and everywhere. So completely second that.
Yeah, I'll just add that we have a 2-pager for those of you who are interested, explaining the importance of jumpstarting a commercial supply chain on the fuel side, especially for high assay, low enriched uranium, which is a type of fuel that a lot of advanced reactors need. And the sense of urgency around this is great, and we just have to make sure that policymakers act on it, as well as it's important that's a big role for industry and the government in a public-private partnership to make sure that we can jumpstart this commercial capability here and with our allies.
And if you would like to take a look at that fact sheet, you can go to nuclearinnovationalliance.org, go to the resources page and type in HALU, and it should pop right up. I'm going to stay with Kay just for a minute so we can close out on her other question. Also, the challenge for nuclear now is demonstrating you can deliver projects on time and on budget. What lessons are you taking from VODL, the VODL project in Georgia? Anybody can jump on that one.
I think I'll start one piece on this. I mean, at the end of the day, I'm thrilled that Vogel's, coming online. It's obviously, I think everyone would like that to have happened probably sooner and at different levels, but it's a real testament to have gotten that set up, given just a tremendous amount of challenges. It's hard, not to also appreciate the challenges the pandemic posed on that. And the value of that clean energy is going to be extraordinary going forward at that scale. But the other thing that's important is this is a dynamic that the industry kind of sometimes forgets about. I'll say we get to learn from doing things, and sometimes things are going to be harder than expected, but the goal is to make sure we take the advantage of learning from those opportunities. I think some of the big lessons that come from Vogel vary by technology and design and approach. I think some value in being smaller can help alleviate some of the potential compounding challenges, but you can also get benefits from the fact we've done Vogel before to help with future big plants being built. So I think it's going to benefit everyone. It's done work to help kickstart a supply chain. It's generated a lot of information, but we have to embrace the fact that this is part of what happens as you scale forward. My dad used to work in solar back in the 70s. And I remember him saying, if we decided to judge everything we do in solar from where that was then, we would have made a huge mistake. Right? The technology gets better, the experience and the project management gets better. Everything is going to continue to improve. I think that's a very important thing to keep in mind about how this is going to proceed, and how we are all building on lessons learned from what those experiences were in our different approaches in different ways, to sort of capitalize on the fact that we already did something, and that there's going to only be lessons learned from that and future ones. So even if future plants have different challenges or different pieces, the value of what's coming forward is important. And as long as we keep applying that fact and learning from those lessons and embrace that iterative mindset, I think we're going to be very successful. But that is a paradigm shift, frankly, from how the industry has thought about these things in the past. You have to embrace the iteration and the learnings.
Yeah, Ben and Jacob, I think you're spot on. But, a couple of things that Dow is specifically looking at is, one, ensuring that the design of the plant is completed prior to starting construction. And that's where we've seen lots of issues is starting that construction phase and not having the design fully vetted, the constructability done. So putting constructors involved in the design process has been really critical to make sure. Also bringing Dow's technology and Dow's experience in building cogen units. We've been doing the billion-dollar projects to build cogen units, and we're treating this like we would a Dow project, like it's a Dow cogen unit. And I guess the second point is, don't make it, everything doesn't have to be nuclear at a nuclear construction site, and making sure that you rationalize what it is exactly needs to be nuclear, and making sure you have the nuclear aspects and the nuclear quality requirements in place. But then where they don't need to be, you don't have to do that, and making sure on the conventional sides of the plant that we're constructing those with absolutely the best technology we can, but not necessarily with all of the bells and whistles that are required by nuclear.
Yeah, and I would like to sort of second both those points and focus on completing the design, right? Like very simply said, but focusing on completing the design. You think you've completed the design, then there's the licensing review that sort of gives you new dimensions to what it is to get it licensed, and then there's construction. So integrating the design has its own challenges and construction itself, but I completely second what Mark said. There is a challenge to making everything nuclear, and that cannot be the vision going forward or the thinking going forward if we are to bring new players and new markets into the industry and into our vision.
Thank you. Judy or Victor, you want to add anything before I move on? Okay. I'm going to try to make sure we hear from as many different people as possible. There's a lot of questions in the chat box here. Siri Hadreen from S&P Global asks, what do panelists think of the ADVANCE Act? Does it go far enough in NRC reform? So I'm going to start with Judy first, because I know she has an opinion on this, and then we'll go to our panelists.
Yeah, we think the ADVANCE Act has a lot of useful reforms. They have, it's a fairly long list of good provisions from our perspective, and a few I'd highlight is they have useful fee reform about how NRC charges fees to license applicants. They also have a useful program to make it easier for NRC to hire outside of the usual processes, sort of special hiring authorities to get the talent they need and to pay the salaries that they need to. These are authorities and incentives that other agencies have access to. And they also have prizes for first movers on licensing, which could be particularly helpful to the early movers. There's also a lot of other useful provisions in the ADVANCE Act, so we are supportive. And there's also there's movement on the House side. The ADVANCE Act is on the Senate side, and the House is also moving ahead with nuclear regulatory reform and DOE-related legislation that's going to be helpful for advanced nuclear energy. So we're excited about the attention and the progress that we're seeing on both sides of the aisle and both sides of the Capitol.
Thanks, Judy. Anyone else want to address that? No, okay, so we'll move on. Question from Dan Yerman at Neutron Bytes, and he thinks it's probably for Archie and Mark. Given the extended timeline for ramping up supplies of HALEU, that's high, let me see if I get it right. High asset, low enrichment uranium. Yes, got it right. How does the current outlook affect fuel fabrication effort for these reactors? So
I'll go ahead and start on that one. Yeah, we're very interested in that. I mean, we're very involved and engaged with X Energy and their fuel supplier TriSoX. We're working hand in hand with them to move forward in that process. As far as what it looks like, it's I will tell you it's tight. We're analyzing those timelines for the manufacturing of the facilities, and then following up with the production of the fuel that's required for our reactors. But presently, we'll have fuel in time for operating our reactors. And we're going to continue to work together as a team to collaborate. The DOE is also very involved with us on this because it's an ARDP project. And I have high confidence that we will get our HALEU fuel when we need it to start up our reactors.
On the MMR side, our reactor can use both HALEU and what we call LEU plus, low enriched uranium plus. So obviously the economics works better with HALEU, but we're working both with industry partners to make sure we have the right contracts in place to allow for us to use HALEU when we actually are able to do that. But the reactors are designed where we can take advantage of the fact that HALEU Plus can be used now, and we can work on deployment with our customers that we're working with deployment this decade using HALEU Plus.
And we'll just stay with you for a moment, Archie. Ben Cross wanted to know if the USNC MMR is fueled at the factory or at the user site.
Right now, the plan is that it'd be at the user site.
Okay, good. Thank you for filling that in for us. We have several questions from Michelle Bellotti from Swiss Nuclear, the Swiss Trading Association. For Jacob and Archie, don't you think there is a risk that many SMR companies are currently over-promising both in delivery date and number of units that can possibly be built per year. And when they will inevitably fail to deliver, people will lose faith in the ability of the nuclear industry to keep their promises. Wow, big question.
Hey, I understand there's some skepticism about some of the details on that. I think everyone's working, as quickly as possible. I don't think we're motivated by anything but making a dent on what's happening with respect to climate. I mean, for us, it's pretty easy to get out of bed. It's pretty easy in the summer, which is unusually hot, to focus on what the urgency is on this, but understand that there are physical limitations and there are realities for how quickly you can deploy. I think we've all been adaptively and updating our projections and how this is going to play out with our timelines. I think, one of the biggest challenges here is on the fuel supply side. I think that's going to be one of the biggest gating functions for how quickly some of these things are going to get forward. And look, supply chain volatility and variability has affected everything, not just nuclear, everything in the last 2 years. And fuel has been compounded by that in some areas. And ideally, we can get those things structured in a way that moves forward on this stuff. I think one of the biggest challenges to me is less around the dates of some of your first plants. It's more about how quickly and where you can get to the scales you want to get to. And I think most folks are being pretty, I think we all think excitedly about what could be done, but also we try to ground ourselves in the reality of what it is going to be the case to get to those levels of build out. A key thing here, though, is nuclear is often presumed to be this thing that people lose sight, frankly, of the reality of how much benefit can come with these advanced technologies in terms of time to build, in terms of supply chain benefits, in terms of volume and inventory componentry production. I mean, everyone here can talk to you about some of the benefits that those things can draw from. I'm sure Mark can tell you all the benefits that they've seen in terms of how they manage a large scale project development and infrastructure. Applying those lessons learned will benefit nuclear, from other industries, and that kind of cross collaboration and cross pollination is going to be worth a lot. I think one thing that's a very, very intriguing and promising dynamic that's going to help us all sort of realize the potential here and as quickly as reasonable deliver into those markets is the following, right? Like, we are at an interesting time too, where we're drawing from best practices of other industries that have done these kinds of scale of deployment very successfully. And we can hire in people from Apple or from SpaceX or from Tesla or name a bunch of different companies. And you see those people wanting to work on really meaningful things like we're all doing in the advanced nuclear space. You get to draw from that experience and apply those things, and that's going to accelerate our learnings. Because if we try to repeat what we've done in nuclear, no way. But that's the beauty of how the world works. Usually you get to benefit from what's worked in other places and apply those lessons and iterate. And I think one really important thing is, I do think this is the thing people think a lot about is, oh, well, what happens if something behind budget or something's not going to work exactly as expected? That inevitably is going to happen in some areas, but that's not a terrible thing because you learn by doing it and you go forward on it. And I think a really neat thing about these smaller size plants in particular is the total cost that it will potentially go to becomes a lot more capped. And not only that, the timeline to build reduces your carrying interest costs, which start to become very difficult when you have a very big plant. You're carrying a lot of interest and delays start to propagate. All in all, it's going to change the dynamics of what sort of being late or being over budget looks like in magnitude. And I think we have to embrace the fact that there is going to be some of that happening. That's fine. That's part of growth. And then what we do is we apply those lessons and then we keep getting better and better and better. This has worked in many other industries. We should look at the same expectations here.
Thank you, Archie.
No, I'll just second that. I think that was beautifully said. And I'll just sort of repeat what Jake said earlier in the meeting. It's like in the 70s, if solar thought that, we wouldn't be here with solar now. So it's the same thing.
And Mark, how come as Dow you decided for X energy design? How did it stand out from the countless of other designs?
Yeah, so we looked at several different technologies. One, if you look at the Gen 3 nuclear reactors, the current technology nuclear reactors, the steam temperatures and pressures just aren't high enough for our applications. What our processes, our chemical processes need are, steam in excess of 500 degrees C, and you just can't get that level with the current technology. So one, that we knew we were able to rule out the current light water reactor technology. Two, when we looked at the different designs, we had to evaluate our requirements for operation. And we operate up to 10 to 12 years without ever shutting down, and no nuclear plants are doing that right now. So one of the things that we've looked at is how can we get that? Well, we needed about one X-energy reactor worth of steam, and we needed about one X-energy reactor worth of electricity at the site. So putting in the two and then putting in two additional to account for redundancy and to build in that reliability that we need, that the size and everything fit, plus with the aging of our asset we knew we had to do something, so we picked that site first, and then we looked at technologies to fit that site. We're also evaluating other technologies and other sites at Dow, pending positive outcomes and progress here.
Thank you. And then Jake, Michelle Bellotti is also wondering when you're going to reapply for license to the NRC after the January 2022 rejection.
Yeah. So, you know, one of the interesting things we learned in that process was some of the challenges, right? We submitted that application literally on March 11, 2020, which was the day the pandemic was declared. We had obviously taken a pretty, I would say, forward-leaning approach on the application process, and something I would contend is important for the industry to do is keep pushing forward and not just try to repeat things from the past. We tried that. We probably went a little too forward in certain areas, and then the communications were very challenging in the pandemic era when we were really anticipating a lot more, you know, in-person audits and parts of that. So at the end of the day, when we got the denial focused on a couple areas of more information requests from the NRC, we immediately started engaging with them back in April of 2022 again, and thankfully got to really hammer through a bunch of those items. We're working through closing out most of those items. We're on a good trajectory to do that, then translating this year to support submitting a license application next year is what we're aiming for. So I think the valuable thing is a lot of things that we pushed forward on, we got some positive feedback on, and some we got some feedback saying, hey, we're not sure if we can do it quite like this. We need more information to support that. And again, take an iterative approach to learn from that and work forward. And I think what's important is this shows that you can do some very different things with the NRC, and the NRC is capable of doing that. And that's, I think, very important to recognizing the actual potential these technologies have. Because if we try to license them like older generation light water reactors, when they're not that doesn't really work. You lose some of the inherent benefits of these technologies. And we each have our different unique feature sets that are important to make sure we sort of organically match in the licensing space. And the NRC is plenty capable to do that. Sometimes it just means industry has to try. And I think that onus is at times on some of these new companies like us. And you live and learn through the process. And the good news is we've learned quite a bit, and including how to, I think, be pretty successful as we go back with them with the submission next year.
Thank you.
I was going to just add one real quick thing. And Jacob, you brought up a good point about the licensing of these plants, and you can't license them and consider them, you know, consider them to be the same as the current light water reactors. You can't operate them the same way either. They need to be operated differently. They're totally different entities and beasts, so to speak, than what we would normally have. So yeah, you've got to think outside the box, break down your paradigms, and operate and run these plants totally different.
So a lightning round, last question. We're not going to get to all the questions. We will follow up by email. Ben Cross asked, how many standardized nuclear reactors with different types of fuel cycles can the market support? Seems very key to the primer and the compendium. So lightning round, who wants to throw out a quick answer? Short.
Huge numbers. I think when you look at what the expected demand is going to be, and I think you expand that to a global stage. I mean, some people say, project out a potential tripling in demand, electric demand on a global scale over the next 50 years. Nuclear is going to play a major role in that. And I think sometimes different analysts can look at this and come up with numbers of anywhere from 1/3 to maybe half of that growth. That translates to hundreds, maybe thousands of reactors of different sizes. And again, that's a big number, but when you look at the math, it's hard not to come to those numbers, and a big opportunity and a big responsibility.
Yeah, and I would direct you to the Department of Energy's Office of Clean Energy Division. They've got a good report that they put out a few months ago that really spells out what the requirements are, not only nuclear, but across the board, what the power requirements are between now and 2050. And nuclear is a part of that needs to be factored in.
Thank you. Archie?
Just second that, huge numbers. Just the amount of data centers and the energy needs that they have require huge numbers out there. So completely second that.
And we had a data center question, which we're going to follow up on. Judy, you get the last word, a quick summary, and then we'll wrap up.
Yeah, I would say, I think part of the question was how many standardized designs, not just how many reactors overall. I agree with the big numbers that everyone has said so far, and that's what our analysis and modeling indicates, is we need a lot more advanced nuclear energy to meet our climate and energy goals. But in terms of the number of standardized design, it's a little bit of a cheat. We don't know how many. And this sort of gets back to the theme that I hope everyone takes away from this, the importance of learning by doing. What's happening now is we have a whole portfolio of a fairly large number of developers who are trying out different designs, and a number of them are going to succeed, and a number of them are going to succeed on different use cases. You know, there may be in a certain type of situation, a very small reactor in a certain type of situation might work out perfectly well. And in another situation, you might need a reactor that has different characteristics and maybe is larger, maybe doesn't have the high temperature heat capacity that the other ones, because that's not needed in that case. So I can imagine we have a portfolio now, and I can imagine a large fraction of this portfolio succeeding, and then you have a set of standardized design, or you can imagine that there'll be competition among these designs, and then a smaller number will win out. But in any event, we have to be moving forward on all of these now, because we need all these shots on goals, and there really is likely plenty of room for multiple designs. And so it's very exciting to see the group of folks we have on this call today, as well as the students and the young professional and early career folks who are moving into nuclear, either out of school or from other fields. And I'm very excited about the different ideas that they're bringing to this space and the multiple successes that we're likely to have. And we have to make sure we define success as learning from doing all along the way.
Well, Judy, that's a great answer and also a great summary of the conversation we've just had. We did ask for an hour of everyone's time, and it is now an hour. So I want to make sure we honor that. Thank you, Judy, for that informative update. And thank you and Victor and the entire NIA team for your work on these terrific NIA resources. As a reminder, the primer, compendium, and maps are all available on the NIA website at www.nuclearinnovationalliance.org. I'm very sorry to Doug and Ben for not getting to the rest of your questions, to Michael Marcianti from UBS for missing your question. I tried to get to it and didn't quite get there. Thomas Fanning will follow up with you. Jackson Culver from PPL Corp will follow up. Chris Godomsky from Bloomberg NEF will make sure Archie gets your question. Ben Cross, appreciate your additional questions. Thanks, everyone. It's wonderful to have almost more questions than we can address in the time. It's great to know there's so much interest. Please join me in thanking our special guests for joining us today, Archie Manoharan, Mark Feltner, Jake DeWitt. We're grateful to each of you for sharing your time and your expertise and for all the work you're doing. And on behalf of the Nuclear Innovation Alliance, thank you to everyone for joining us today. And I wish you a happy summer and have a great week.
Thank you.